I'll be discussing preparation of hydrogen in this video, where starting with the first preparation method, that is preparation in laboratories. So in laboratories, hydrogen is prepared by using granulated zinc metal, where zinc is taken in the presence of dilute HCl. This HCl will provide H plus ions, and zinc will lose its electrons. Those electrons will be gained by H plus to convert into H2 gas. So zinc will lose two such electrons, and two such H positive ions from the dilute HCl will react and form H2 gas along with the formation of zinc 2 positive ion. So in laboratory, by using dilute HCl with the granulated zinc, this is how hydrogen is produced. Or it could be like zinc is taken in the presence of sodium hydroxide, that is a base. Here in the first method, dilute HCl was used. In the second method, in laboratories, sodium hydroxide is used, where it would convert into hydrogen gas plus sodium zincate, Na2ZnO2 as a byproduct. So that's how it is produced in the laboratories. Commercially, hydrogen is produced by electrolysis of water, acidified water. So, as we know that electrolysis is the process where electricity is provided in a cell containing two electrodes. One is cathode and one is anode. So these are the two electrodes, and this is electrolytic cell. So these are two electrodes, one is anode, another one is cathode. So for this process, these electrodes are of platinum. Hence, as we know that in electrolysis on anode, the process that occurs is called oxidation, while on cathode, reduction happens. So, as we know that in water, they are basically H plus and OH minus ion. Therefore, H plus can gain electrons to form H2 gas. 2H plus will give 2 electrons to form H2 gas. Since there is gain of electron in this reaction, gain of electron is called reduction. So H plus ions are reduced to H2 gas. So this process is the reduction process, and reduction process happens on cathode. So during electrolysis, on cathode H2 gas will be released. While the OH minus ions, these ions will convert into O2 gas with the removal of electrons. or we can say oxide 2 minus ions will convert into 2 such oxide ions will convert into 2 O2 gas plus 4 electrons. So this there is release of electrons in this process, release of electron. This is called oxidation. Gain of electron is called reduction, while the release of electrons is called oxidation. So since oxidation happens on anode, so during electrolysis of water, anode oxygen gas will be released. So overall, during electrolysis, we have two electrodes, anode, cathode, when you are doing electrolysis of acidified water. So cathode will release, on cathode H2 gas will release, and on anode O2 gas will release. Other methods are also there to produce hydrogen gas using electrolysis process, where barium hydroxide solution BaOH2, it's a barium aqueous solution of barium hydroxide, that is BaH2, in presence of water. Electrolysis is performed with the help of nickel electrodes. Here we use platinum electrodes. So in the presence of nickel electrodes, barium hydroxide plus water in the electrolysis will also release H2 gas, and that gas will be 99.5% pure. The process provides 99.5% pure hydrogen gas. So these are the methods where hydrogen gas is produced commercially using electrolysis process. Other than this, okay. Other than this, we have method where um, in the formation of sodium hydroxide. So during the formation of sodium hydroxide production, sodium hydroxide is production from saturated brine solution. So what do you understand by saturated solution first? Saturated brine solution. Excuse me for my handwriting. I am new with this pen tab. So for brine, what is a saturated solution? A saturated solution is something when you are adding a solute to a solvent. Let's suppose you have a container that contains some solvent. Let it be water. Okay. So you have water in this beaker. You are adding NaCl as solute. You are adding salt. You are adding salt to this water. There will be some point where the salt won't dissolve to the water, rather it will start sitting at the bottom of the container. At that point, when the solute is not soluble in the solvent, it has attained the maximum solubility. That means the solvent has occupied maximum amount of solute, and it cannot dissolve more than that, and further addition of solute settles at the bottom of the solvent. It is not it is not getting dissolved in the solvent. This type of condition is called saturation. So for so when electrolysis is done for the saturated brine solution, that means there is excess of the sodium chloride in water, excess of the solute in water. When electrolysis of this saturated solution is done, it has been observed that the sodium chloride, which contains Na plus Cl minus ion. These Cl minus ion actually undergo oxidation. Two such Cl minus ion converts into Cl2 gas plus 2 electrons. Now we know the process is oxidation. Oxidation happens on anode. So during electrolysis process, there we have two electrodes. So on anode, when you do NaCl saturated solution electrolysis, NaCl, anode will give Cl2 gas. While since it is a saturated solution in water, so the water will gain the released electrons from NaCl minus ion and will form H2 gas and will release 2 OH minus ion. These H2O basically is H plus and OH minus. So these two H plus ion will gain these two electrons to form H2, basically 2 H form H2 gas and or 2 OH O minus ions will be released. So overall we can say that the saturated NaCl solution, that is Na plus Cl plus H2O, will give Cl2 gas on anode, since Cl minus converted into Cl2 gas by releasing of 2 electrons, and the H2O, that H plus ions, gain 2 electrons to form H2 gas. This will be formed at cathode. Along with that, there will be formation of 2 Na plus ion plus 2 OH minus ion. So this will combine to give NaOH. So the electrolysis of NaCl process is important as it gives H2 gas as byproduct plus Cl2 gas plus sodium hydroxide. So you can gain three such important substances from the electrolysis of saturated NaCl. After this, the other method to prepare hydrogen gas is the reaction of water, that is water with saturated hydrocarbon. You can say saturated hydrocarbon. We know that alkanes are saturated hydrocarbon. How do we write alkanes? Alkanes, general formula for writing alkanes is this, like CH4 if you say. So here N is 1 and hydrogen will be 2N plus 2. So hydrogen will be, and since N is 1, so fill it here. 2 into 1 plus 2, that is 2 plus 2 will give H4. So for CH4 is a saturated hydrocarbon, that is methane. So for any saturated hydrocarbon, when you react with the H2O in the steam form, this reaction takes place. So any saturated carbon or hydrocarbon will react with water only when you provide extreme conditions of temperature and pressure. You need to provide such extreme conditions to make the reaction happen between water and hydrocarbons. Since we know that water doesn't react, water won't react on its own with the alkanes. It will react only if you provide high temperature and pressure in the presence of catalyst as well. So for this process, the catalyst is nickel. So the product that will be formed is carbon monoxide plus hydrogen gas, which will be formed in this amount. So this is a general reaction that if you will react any hydrocarbon, you will get 2N plus 1 moles of H2 gas and N moles of carbon monoxide. So let's write for one example for this, where let's take the simplest one, that is CH4. If CH4 is reacted with the steam, that is water, at high temperature and pressure, obviously water will convert into gas. So at high temperature, so for reaction of methane, it requires 1270 Kelvin in the presence of nickel. So as we saw that N moles of CO forms and 2N plus 1 moles of H2 gas is released. So for methane, N is 1. So 1 mole of CO will be released along with 2 into 1 plus 1, that is 3 moles of H2 gas will be released. Also, one important thing here to understand that the mixture of carbon monoxide CO plus H2 is called syngas or water gas. Since this reaction occurred with the water at high temperature, that's why it is called water gas. If you want to convert, if you want to make more of the after now we understood that CO plus H2 mixture is called water gas. If you want to produce more amount of H2, you can shift the reaction. Shift this reaction of hydrocarbon plus steam, hydrocarbon plus water to produce more amount of H2. How can you shift this reaction? You can shift this reaction by increase by reaction carbon monoxide in the presence of you can increase the reaction in the presence of further using a catalyst, which is iron chromate, which is FeCrO4, iron chromate. Okay. So, you release this carbon monoxide and water. After this, adding catalyst, that is iron chromate, to this in the presence of 673 Kelvin, there will be production of CO2 gas, CO2. This carbon monoxide will be converted into CO2 along with the more production of, here is water. So, if you add water to the above syngas mixture, where H2 was already present. In the syngas mixture, you have CO plus H2. To this reaction, if you add water in the presence of this catalyst, the reaction will produce carbon monoxide and more amount of H2 will be released. So this reaction where you add water to the syngas, this is syngas or water gas or water gas. This reaction where you add more amount of water in the presence of catalyst to the syngas, water gas or syngas plus water in the presence of catalyst, and you get more of H2 gas. This reaction is called water gas shift reaction. Shift reaction. So we understood today how hydrogen is produced. Hydrogen production. Hydrogen is produced by in labs with the zinc plus dilute HCl or NaOH solution, or it could be produced by by electrolysis of water or barium hydroxide solution or saturated brine solution, which is NaCl solution, saturated solution. And we understood also it could be produced by further process, that is reaction of hydrocarbon plus water at high temperature high with catalysts. Here you understand two important reactions, that is one is water gas formation or syngas formation, and how can you shift this water gas, how can you make more of the hydrogen by shifting this water gas shift reaction, that is water gas shift reaction. You understood. That's all for today. Thank you.